Today's lesson still is dealing with completing the square. So the same goal still applies. Okay, so how to complete the square when a does not equal 1. Okay, so let's look at this example. We want to change negative 4x squared plus 24x plus 8 into vertex form. Now, what we're going to do first of all is we're going to start the same way by putting brackets around the first two terms, the x squared term and the x term. Okay, because we know that in vertex form, the x doesn't have a coefficient, right? So we're going to divide that coefficient out of the brackets. So we're going to start with putting, first of all, a bracket around our x squared term and our x term. And now we're going to divide out the negative 4 because x doesn't have a number in front of it. So if I take out a negative 4, what am I left with? Well, this term becomes an x squared. This term is going to become a negative 6x. And again, we still have our plus 8. Okay? So that's what we have. So we have to always factor out whatever is in front of the x squared. Now, like the other one, let's take a look at just this bracket in a sense. So remember, what I'm showing you here is just to understand how the process works. So I know, what do I need to put in here so that in this brackets we have a perfect square? So negative 6, half of negative 6 is negative 3. Negative 3 squared is a positive 9. The reason we did that is those three terms there become x minus 3 squared. Okay, now this line does not equal this line because we've changed the value of this by not adding and subtracting. So I'm going to stroke that out, but that's the process that we're going to be looking at. All right, so just like the last time, you just can't put something into an equation and change it. So whatever you put in, you must also take back to restore the balance of the equation. Always has to balance. Now we're going to pull the bracket in, but this time when you pull the bracket past the correct term, remember that the number in front of the bracket belongs to it as well. So to put the bracket in, you must multiply that extra term by the front number. And I'll show you exactly what I mean by that. Okay, so here I've added 9. So if I added 9, I also have to subtract the 9. Now the problem is that the first three terms I'm interested in, okay, are in the bracket. That's the perfect square. But the problem is this negative 9. When I take that negative 9 out of the bracket, before what was in front of that bracket was a positive 1. This time it's a negative 4. So that means I have to, when I take that negative 9 outside the bracket, I also have to multiply it by the negative 4. So negative 4 times a negative 9 would be a positive 36. Okay, and the reason it's positive 36 is because remember it's negative 9 times the negative 4. We also still have the plus 8, so it has to be there. So now our first, oh, we're missing our 4 here. 4 should be out here. So what we have then is 4 bracket x and this perfect square, which would be minus 3, and then a positive 36 plus an 8, so we're looking at a positive 44. All right, so let's do some more together so you get a little bit better understanding of what's going on. Okay, the next one. So the first thing I need to do is I need to put brackets around the x squared term and the x term. I need to factor out the 2. So when I factor out the 2, what I'm left with is, in the bracket, in the green bracket, is an x squared plus a 10x. Close my bracket. Oop. Actually, I put too many steps in there. I think I would prefer you to do pull out the 2, we have an x squared plus 10x, close the bracket, plus the 43. Then I would take half of the 10, square it, so that's 25, and subtract 25. Okay, so now remember the first 3 terms are the perfect square. So when we take them, we end up with 2 bracket x squared plus 10x plus 25. When I take out the negative 25, remember I must multiply it by the 2 in front. So 2 times negative 25 is a negative 50 plus my 43. In the bracket, we have the perfect square. So x plus 5 squared, negative 50 plus 43 would be a negative 7. Next question. Put brackets around the x squared term and the x term. We need to factor out the negative 3. When I factor out the negative 3, I end up with an x squared. Negative 18 divided by negative 3 would be a positive 6x. Now we can continue this. Okay, so we've got that. We want to take half of 6 and square it. Half of 6 would be 3. 3 squared would be 9. So I'm going to add 9, subtract 9, close my bracket, and I have my positive 13. Remember, the first 3 terms are the perfect square. When I take negative 9 out, I must multiply it by negative 3. So that becomes a positive 27. And I also have the plus 13. Okay, here's our perfect square. So negative 3, x plus 3 squared, positive 27 plus 13. So we're looking at 40. Okay, here's the one that's got a fraction. Same process, however. When I put a bracket around these 2, then what happens is, and I think we're going to do this one a little bit different. So when I factor out a half, I'm left with x squared. When I divide negative 2 by a half, so negative 2 divided by a half, because that's what we're doing. Okay, that's the same as negative 2 times 2 over 1, which would be negative 4. Okay, plus the 5. Now, if you're a little unsure about that, if you notice I took it out here so I could see it, you also could actually then expand this to see if you're getting what we have in this first line, which you would. Okay, so we end up and we take half of the x term. Half of negative 4 is negative 2. Negative 2 squared is 4. So we add 4, we subtract 4. That's a 4, by the way, not a 9, plus 5. The first 3 terms are the perfect square. And we'll just do that exactly the way we've done all the rest. When I take the negative 4 out, I must multiply it by the half. When I multiply negative 4 times a half, I end up with a negative 2 plus the 5. And lastly, it's just a matter of cleaning everything up. Here's our perfect square. So we're going to put x, and it's going to be minus 2. And we end up with a plus 3. Okay, so a few more steps when we have a coefficient other than positive 1 for our a value. So what you're going to do now is you're going to actually practice some of this for yourself tomorrow in class time. Remember, it's something like factoring in the sense that you have to practice that because of the steps. Notice I was talking myself through. That might be what you have to do with yourself as well. Have some fun tomorrow with some math.